Hello everyone. Before we start talking about the video, I just want to give a shout out and I want to thank the new subscriber that I had in the last 2 weeks. So thank you very much. Right now I have 2 subscribers, which gives me the motivation to create more useful videos for you and for everyone who's watching my videos. Now, what is the purpose of the title of this video? When you ask people about Kubernetes, or watch videos or try to do some research online, you will see a lot of demotivation. You will hear things like Kubernetes is a container orchestration, or you need to manage your clusters, or you need to, etc., etc. And you will hear all these complicated words, and you will think that Kubernetes is something that you probably don't want to do. But this is far, far from the truth. And in this video, the purpose of it is to, using a sample practical application, we are going to apply all the components of Kubernetes to show you what it can do and how useful it is, whether it was for your project or if it was for your organization. That being said, let's jump into the Kubernetes components that we are going to discuss today. Let's start with ConfigMap. Now, when you have a lot of microservices, it's very common that you are storing your configurations somewhere, and some of these configurations are for specific services, and some of them are common for multiple services. But regardless, having a place where you store your configuration is something that you would almost always need. And that is what ConfigMap is. But just be careful, ConfigMap is not used to store sensitive data, just like passwords. So where to store that sensitive data? This is where we use Secret. Secret would be the place to store your database credentials, for example, as we are going to see in this video. And there are different types of secrets, but this video is just for a basic overview, just to get your foot in the door. And then there is pod. So a pod is instance. That's what I love to call it. It's not the exact definition, but it's my practical definition of what a pod is. It can consist of either one or multiple Docker containers. Now, the only time where you want to have multiple containers sharing the same pod is if there is a tightly coupled relationship between them. And in the Kubernetes documentation, they provide an example where you use WordPress with the, I think, Nginx and the database all together in the same pod. But typically, one pod is one instance for one application. So that is for pods. Services, what is service? So taking the example of pod, taking when you scale your application, or like if something went wrong within your applications or pods, they get destroyed and then new pods gets created. And when that happens, the IP address changes. So if your microservices are communicating among each other, that will cause a lot of problems. And this is where creating a service for these pods comes in, because it will create some sort of a domain name that will easy the communication between these microservices, and it will also bind that domain name with a static with a static IP address, so that when your application is scaling up or down, or when your pods are destroyed or created, you don't need to make any changes to your microservices configurations. So that is the first purpose of using a service. The second purpose is to expose your pods or your deployments, because by default, all your application deployments, all the instances, all your pods are private within the cluster, and are not exposed outside. But if you want to expose your pods, for example, for a website, then using a service would be the way to go. Okay, now before we go into deployment and stateful set, I want to mention that we have two types of applications in general: stateless applications and stateful application. What is the difference between them? If we take the example of a website where your users are interacting with that website, if for some reason your website instances are going up and down or getting destroyed and created, you don't want the user experience to change, or you don't want a state to be attached to that instance when your instances are being created and destroyed because of scaling. So in that case, your applications must be stateless if you want a smooth experience. So a good example of stateless applications are basically most of the microservices. And on the other hand, if you want a application that stores its state when it gets destroyed and recreated, then you want to use stateful pods instead. And a very good example is the database. So when your database gets destroyed or recreated, you want your data to be maintained. So if you are managing stateless applications or pods, go with deployment. If you want to go with stateful pods, go with stateful sets. And last but not least is Ingress. And in two words, Ingress is an API gateway. So let's say that you have a team that manages 6 microservices. So when other teams are calling your services, instead of calling different URLs for each service, you would have a shared URL, which would be your gateway, and you would have different paths for each microservice. So that would what Ingress is all about. Now, that being said, the only component that we are not going to discuss in details is the stateful set. Why? There are two reasons. Reason number one is it's a little bit complicated for this introductory video. The second and the most important reason, it's because it's not recommended to be used in general when you want to create databases. Even though you can create databases in Kubernetes, it's recommended to use the database as a service that is provided by your cloud provider. So that is why, in generally, instead of using a stateful set for databases, just use the database by your cloud provider. It's much easier. It's easier to maintain, etc. Now we are going to create a database, and that would be using a deployment since it's easier. And even in the Kubernetes documentation, they are using deployment for a single instance. But like if you had multiple instances that are interacting with the database, you almost have to use stateful sets. Okay, now that is all covered. Let's start by creating our database. Okay, now before we do that, how are we going to create a Kubernetes cluster? Now, one of my main principles is that all my videos must use free resources. So we are going to do all that locally. Now, typically, when you are on the cloud, you would have a node so each computer would be a different node. So there would be like one master node and worker nodes. I won't go into details of how Kubernetes is actually works behind the scenes. There are a lot of videos about that. But locally, there are a lot of tools that you can use to run Kubernetes on your local machine. And the example that I'm going to use is minikube. So what are the prerequisites before you continue along with this journey? you need to have Docker installed in order to make minikube to work correctly. So Docker is the only prerequisite. Besides that, everything should be good. And a small disclaimer, I am using the Windows subsystem for Linux on my Windows 11 machine. I am saying this because you might see some differences on how to interact with minikube. There are other tools like Kind, and I know there are others as well. And since it's different to be installed for each machine, I would recommend going to the website and looking at the documentation and how to install it based on your operating system. Okay, so what are we going to do in this video? We will have one application that performs CRUD operations on a database, something that you would almost always see in any company, in almost any job that is related to interact with backend APIs. Okay, so how are we going to do that? First, we are going to create our database using Kubernetes, and we will have a small overview on how to achieve that. So I'm going to open my terminal briefly. And to start minikube, you have to run minikube start. And of course, this is after I've already installed minikube on my machine. It's going to take some time. Until that happens, I will open the link of the sample on how to create a database in Kubernetes from the official documentation, which, as I mentioned, they use deployment. Now, there are two ways to create resources in Kubernetes. One is using the command line, kubectl. So kubectl is like the command line tool that you use to interact with Kubernetes. The second way is to create files and then apply those files. And that's what we are going to do mostly in this tutorial, but we are going to see how we can use kubectl to create resources without creating files. So I will just copy this file and then I will explain in details what all of this is about. So don't worry about that. Okay. Okay, so now my minikube has started successfully. Let's create a new file. Let's create a new directory. I will call it SQL and I will go inside. Cannot create directory, file exists. So okay, this is from my previous preparation. I'm going to delete everything that's in here. Okay, now I'm going to create my configuration file that is going to create the resources based on what is written on this file. I'm going to paste, I'm going to make some changes, but before I do that, I will explain what these lines actually mean. So let's start with the API version. So this is a YAML syntax. If you don't know much about YAML, I recommend that you do some reading before continuing. The three dashes is to separate the resources, and this is YAML thing. It has nothing to do with Kubernetes. So the first section is creates a service, and the second section creates a deployment. And typically, the service and the deployment are related to each other, which is why they are usually created within the same file. So let's start with the service. So the API version v1. Right now, all the services, all the resources, I think they are v1. I didn't see v2 yet in Kubernetes. The kind. So am I creating a config map? Am I creating a secret? Am I creating a deployment? This defines the resource type. And any resource must have a name. So it must have a metadata with a special unique name. Now, you can create as many metadata as you want, but you must have one metadata for your resource name. So we are going to use MySQL as our database. So that's what this line is about. And spec stands for specifications. So MySQL by default runs on port 3306. So that's what it means. And selector app MySQL. What is that? We will see what that means in the next 5 minutes. So don't worry about this line. Cluster IP none. No, so services in Kubernetes are actually divided into three categories. By default, it's of cluster IP type. There is also node port and there is load balancer. By default is the cluster IP, which is not going to expose your service publicly. Now there are two types, which are the node port and load balancer. Typically, when your service is on a cloud provider like Google Cloud or AWS, you would pick load balancer, and that load balancer Kubernetes is going to use the load balancer that is set on your cloud provider. If you are doing things locally, typically you would use node port. Now, the problem with our database, we don't want to expose our database, right? We want it to be as private as possible. So not only that we are not exposing it, we are also setting the IP to none so that it won't have an IP address. That's how private it is. Now, the second type is deployment. So the API version, this is constant, so it's version 1. And the kind is deployment, which is the kind of your resource. And as I mentioned, any resource must have a name. So this deployment has a name, which is MySQL. And let's go to the specifications. And we have this selector, and it says match labels app MySQL. And a disclaimer, this selector works the same way as this selector, which I said will take me 5 minutes. Now we are very close to know what that means. So the strategy, there are two strategies in deployments. There is something called recreate, and there is something called rolling update. By default, it's rolling update, but if you want to change it to recreate, you add these two lines. And what that means is when you are scaling your applications, or when you by destroying and creating your pods, it's going to destroy your pod first, and then it's going to create a new pod. So that's what recreate strategy is. But if you are doing rolling update strategy, then you can either specify uh, explicitly here, or you can delete these two lines from your file. The template, now, this is the reason why we have the selectors here. Now, there are two ways to create your pods. You either create them in a different file or in a different configurations, but typically, since the deployment is very, very coupled with your pod, you would create your pod, or you would specify your pod configurations inside your deployment configuration. So this template here that you see is related to your pod configuration, and it's assigned a metadata, and that metadata is a label. And what is the label? App MySQL. So if you look at the service at the top, what that does is it's saying, hey Kubernetes, your service is for the pod that has this label. So by specifying the label here, I am telling my service which pod it should reference to. The same goes for my deployment, right? I am saying manage the deployment for the pod for this label. So that is the explanation. Let me scroll down. Now my pod, which is under template, this is a pod template. It has this metadata for my service, for my deployment, for any reference to that pod, and it has specifications. and that specifications has a containers. As I mentioned previously, a pod can have one or more containers, but over 90% you are going to have only one container, which is going to be in this case. What is this container? It's a database, which is MySQL. So I'm using the MySQL image. And by default, this is using Docker Hub. And we name our pod as MySQL. Environment. What is env? It stands for environment. It's the environment variables that you pass to your Docker image. We are going to see this shortly, actually. So let me scroll down. The port, it runs on port 3306, which is the default. What is the volume mounts and what is the volume? Since it's a database, we want to store the data somewhere so that it's persisted, so that in case pods are destroyed and created, in case deployments are destroyed and created, the data is not lost. So that is the purpose of this volume mount thing and this volumes. So I am saying this pod stores the data in this volume. It's mounted to this volume. And what is that volume? This volume is specified here. So I'm saying mount the pod to the volume with this name. And then here I'm specifying the volume, and that volume is taking the volume from something known as a volume claim. Okay, what is a volume? What is a volume claim? What is all that stuff? In 10 minutes, you will know all that. So, I said I will go back to this environment. Why is that the case? Is because I'm actually going to add more configurations and more environment variables for our use case. This is the documentation for the MySQL image. And what I want to achieve in order for my application to connect to MySQL, I actually want to create a new database when the image is created. And I also want to create a user and a password for that user. And I want that user to have access to that new database that will get created. So if I scroll all the way down, you will notice that in order to create a database, I can pass this environment variable, and I can pass this to create a user, and I can pass this to create a password. Now, I can hard code all of that, but the purpose of this video is to learn. So, how are we going to pass our configurations? We are going to use ConfigMap, and we are going to use Secret. So, let me go back to the terminal. I am going to exit this. I don't want to save anything for now. Let me create config.yaml. And you can look at the documentation. So for example, I can say config map. And that is the easiest way if you forgot how to set your configurations. So I'm actually going to pick this since this is the most simple way to do it. And I don't even need this in our use case. So creating a config map is extremely easy. You just specify the version, which nowadays it's always v1, the kind config map. Now you start to see consistency on how we do things. Now we said that any resource, what does it have? It has a name. So I will call this configuration database. And what is data? Now, data is like a list of key value a list of key value pairs or values for our configuration. Now I'm going to store only one configuration, only one key value, which is the database name. And for the user and password, I will store that in the secret. So let me name this demo, just since this is a demo. I will save this and I will create this. Actually, let me just do cat config.yaml. You will ask me why. Because the way to create secret is actually very similar to the way that you create your config. So the only difference is, actually there are two main differences. The first difference is you specify it as a secret, and for the data, there are actually two ways to create the data. But let me specify the user and the password. Let's say this is password 1, and let's say this is user 1. This is not going to work. If you want to pass the data into a secret, you must do base 64 encoding. How to do the base 64 encoding? The easiest way, let me open a new terminal, is to say echo and the value itself and the pipe operator and say base 64. And then you can pass that like this. And you can do the same thing for the password. But just to avoid confusing you, I'm actually going to hard code it, and instead of using data, I'm going to use string data. And the difference between data and string data is that with string data, you don't need to do the base 64 encoding. So I'll keep it like that, and I'm going to save this. Now, how am I going to apply my configuration? The command is kubectl apply -f and then your file name. Now this is created, great, and this is created. And now I'm going to reference these values in the deployment.yaml that I wanted to create initially. So let me go back to this example. And I will scroll up. Now you will notice that I'm using spaces and not tabs because YAML files do not like tabs. Just in case anyone is actually wondering. Okay. So now this is the database, and here we provide the database name. Now, since we are referencing from a configuration file, we are going to say value from instead, and we are going to say config map key ref. That way, I'm telling to Kubernetes that I am actually referencing my value from a config map with a specific name. And what was the name of my config map? It was database. And what is the key? The key is name. If you remember, I had only one key, and that key was name, and the value of that key was demo. Okay? Let me do the same thing for the user and the password. And don't worry, all of this will make a lot of sense when I create my app in the next step after I create my database. Now, the user and the password are stored inside a secret. So in that case, I'm going to say secret keyref. And the way to reference is the same thing. So our secret is called database, and the key is actually user, right? And the value of that user was user1, if you remember. And the last but not least, the password. Value from secret keyref, and the name is database, and the key is password. Now we are all good. I'm going to save this file, but before I apply that file was dependent on something called volume. And I actually forgot to mention what a volume is, which is my bad. So what is a volume? So since this is a database and we want to store our data, there is actually a component called persistent volume, and it will tell Kubernetes where to store that data. That's the answer in short. So I will call this volume.yaml, and it consists of a volume and it consists of a volume claim. I will start with the persistent volume. It has, of course, a metadata, and now depending on where you're using your Kubernetes, since I'm using it locally, the type would be local, but and the same goes for storage class name. However, this volume component is actually a huge topic, and for each cloud provider, it's actually going to be different. So make sure to look at the documentation. Now, since I'm talking about documentation, I am actually going to replace this. This is fine, by the way. So I can store my um, data in the amount/data. This is fine, but I'm going to store it in slash data slash demo. Why is that? This reason is related to minikube. So I'm going to search for minikube persistent volume, and I will read the documentation with you. It will tell you that minikube is configured to persist files under the following directories. So if I am persisting the volume in a place that is not under here, and I deleted the minikube, I stopped it and I restarted, etc., the data will be lost, which is why I stored it under slash data, as you can see here. And the claim is, so that volume could have a storage of 100 gigabytes or 1000 gigabytes. Typically, you don't want to like preserve the whole volume or the whole storage in that host path, right? So I'm telling to Kubernetes only request 20 gigabits or gigabytes. So that's what a volume claim is. It claims a specific storage that is inside this path. So that's what the persistent volume is, and the persistent volume claim is, and that's the one that we referenced when we created our um, our database in the deployment.yaml. So actually, if I went back to the top, if you remember, this was the volume. This is the claim name. Sorry, MySQL PV claim, which is the same one as here. So that's how it was referenced. Now, since we need to create, since the database is related or dependent on the persistent volume, I am going to apply the persistent volume first. But before I do that, and I did this intentionally, your volume must be empty before you create your database in this example. Otherwise, the database is not going to be created. And what I mean that database is not going to be created, I mean the new database that I named as demo. It's not going to be created unless the volume was empty. So how do I make sure that the volume is empty? I am going to go inside the minikube. So if I did docker ps, this will show you the current running containers in my machine. And minikube uses Docker, as I previously mentioned, and it has this name. So I'm going to run docker execute -it and then the container name bash, and that will allow me to go inside my minikube container. And I will go inside the data folder, and if you remember, I called my volume at the path for my volume was /data/demo. So I did ls. It is already created. Why? Because I was preparing for this video before it was created, before it's showed here. So now I'm going to delete this folder and I'm going to exit. And now we should not have any issues anymore. So let me apply my volume first. Now it's created. Let me create my deployment. And how do I like look at the status of my deployment? You would say kubectl get, and then you would specify your resource. So if you want to look at your service, you would say service and the service name. You want to look at Ingress, Ingress, and the Ingress name. Now I'm going to say deployments just to see all the deployments for now. And I only have one, and it's already started. And this is one of the amazing things in Kubernetes. It's super fast. Okay, so just to make sure that the database was created successfully, I am going to go inside that database, and the documentation provide a way to do that. And just briefly, this describe command will show you a lot of details of your resource. So it can apply to a deployment, to a service, to a pod. It will show you all the configuration of that resource. And you can also search for a resource by a label. So that's -L is referring to the label. I'm going to run this command. And now I'm going to say show databases. And as you can see, the demo database was successfully created on instance creation. Okay, now before I exit, I actually want to create a table inside this demo. Why I want to do that? Let me go to the application that we are going to create. I'm going to use this sample application that was created by gentleman Ivohonin something, and it just performs CRUD operations on a user's table. And based on his documentation, we need to create a table called users with the following fields. So let's go ahead and do that. Create table users name, which is a string, so I will make it a varchar, and an age, which is an integer. Create. Now the table was created. Now I'm going to exit MySQL as all the preparations are done with regards to the database. Okay. Now the second step was actually to create this application. So let's go ahead and do that. I'm going to clone it. Get clone. And let me go inside. Now let's read the documentation again. Now, based on his documentation, I need to ensure that the user.js contains the correct connection details. So if I did nano user slash user.js, this configuration would need to change based on my database, based on my user, based on my password. Now, I can hardcode them, but remember, I created a configuration to make my life easier, which can be shared across multiple services within my Kubernetes. And I am going to pass this as environment variable. So let me do that right now. So this, in order to access an environment variable, you use process.env dot and then the environment variable. I will do the same thing for the database, and I will do the same thing for the password. Now you might be wondering, what about the host? And I wanted to hard code that on purpose. But just give me 1 second. Let me just do this and this and that. Okay. Now I am going to reference to MySQL. So should I provide the IP address or what should I do? Remember, When we created our database, we created a service. And what was the name of the service? Let's go back to the top. It was called MySQL. So actually, I can just say MySQL. And Kubernetes is intelligent when it comes to domain namespaces and domain name references. So when I say MySQL, it will immediately know that I am trying to call the MySQL service. That's how amazing Kubernetes is. I'm going to save this file. And now what is next? Now, in order to use Kubernetes, we need to Dockerize our application. So how do we do that? This is basic Docker knowledge, but I will go through with you. It's very easy. It's not rocket science. So you would need to start by creating a Docker file. So what is the next step? How to create your Docker file? First, you need to reference the image. Now, since I'm using a Node application, I will reference the Node image, right? And it has multiple versions. I'm going to use version 14. The second step is to create a work directory. What is a work directory? It's where your application is stored within your Linux container. It can almost be stored anywhere you want. For now, typically I will store it under /home/app, but you can store it almost anywhere on that machine. So it doesn't have to be /home/app. What is next? I want to copy the files that is in my current directory to the Docker directory. So I'm saying copy dot dot. The first dot refers to all the files in my current directory. The second dot refers to pasting the files that I copied into the work directory that I mentioned here for Docker. So what is next? How do I run my Node application? This application uses Express, but if you want to use Node, what is the first thing that you do? You run npm install, right? So this run command is used to run any build steps. So we run npm install. So what is next? Now, in their example, the Express application is running on port 3000. So I'm going to say expose 3000. And last but not least, after you install Node, how do you run your Node application? You say Node and then you specify your JavaScript file. And in this guy's example, the starting point is in the index.js. So you would say command node index.js, which is equivalent to say run node index.js to start the app. And I think that's all there is to it. It's that simple. You copy your files, you install Node, and then you run the node index.js command. That's what you're telling Docker, and you're telling it that it's running on port 3000. I'm going to save this, and I want to run ls because I have not run this locally. But if I did, I would run npm install. And after you run npm install, you will see the node modules folder getting generated. Now, typically, you don't want to copy that. It's very huge. And you want to ignore it. Even when you deploy to Git, right, you add the node modules folder to your Git ignore. So is there something equivalent in Docker? The answer is yes. The answer is you would create a file called dockerignore, which is very similar to Git ignore. And I will just specify the node modules folder. Now, since I didn't run this locally, it doesn't really matter to have this, but practically, you would want this so that your build is much faster. Okay, now we created our Docker file. We are going to build our image and push it to Docker Hub. Of course, when you deal with a cloud provider or within an organization, you will push to somewhere else beside Docker Hub, whether it was the container registry or whether it was the ECR, it depends. So the command to build is docker build, and then you specify the path of your Docker file. So the Docker file is in this current directory, so I add dot, and you need to tag it, and this is very important. And you tag it by the user slash your image name. So my user is called Lasirani. This is just a random user I created over 10 years ago. And I will show you my Docker Hub soon. Actually, let me open Docker Hub right now. So if I went to repositories, it's empty. And then you can name the image whatever you want, but you want to be consistent. Now, since this is called node hero, I will call it hero. And after we build our Docker image, we are going to push that to my Docker Hub so that it can be retrieved when we create the deployment for this application. Docker push, and again, let's run slash hero. Now, when you run this the first time, it's going to take some time, but Docker is a little bit intelligent. So when you run this for the subsequent times, it's going to be much faster. It has some caching mechanism, etc. Okay, it's already done. And if I refresh the page, you'll see that my image is already published, as you can see here. Okay, now we are going to create our deployment file for Kubernetes. Sorry, for this application. Now I can create the file from scratch, but we should work smart, but not hard, or hard if we have to. But in this case, we don't. I am going to copy the file from the MySQL, and I will make small adjustments. So I will say cat SQL slash deployment.yaml. Let me copy all of this. I'll call this app.yaml. Let's call it hero.yaml, just to be, since the application name is hero. And now what are we going to change? We want to create a service, obviously. Now here, it's very important that unlike the database, we actually want to expose our service because this is an application, right? So we need to do two things. One is we need to delete this line because we want to expose our service. And the second thing is I want to specify that the type of this service is not port. Now, as I mentioned, there are three types. By default, there's cluster IP, which doesn't expose your service. There's not port, and there is load balancer. Now, load balancer is typically used when you have a cloud provider. You can use load balancer with minikube locally, by the way. It's a little bit maybe, it can provide you some headache, but it's possible to expose it. But I'm going to use not port for simplicity. The second thing is the port. Now, since it's an application, right? So most applications are either on HTTP or HTTPS. And typically, if you want it to be more secured, you want it to be in HTTPS. So in that case, it would be 443, right? Because that's where HTTPS is. But since I am not creating a certificate, since this is a simple example, since I'm running this locally on my machine, I am using the HTTP protocol, so the port would be port 80. Now there is something called target port, or is it port target? Target port or port target? I don't remember. So that's a good question. So how do I remember that? I will just search for target port. Okay, so it was target port. So what is the target port? It's the port of where your container is running. So my container, which uses Express, is running on port 3000. So that's why I'm specifying this as 3000. And what is the name of the my service? Hero. I will call everything as hero. So hero and hero. Let's go to the deployment. Again, hero. Match labels, hero. And here, since this is not a database, this is just an application, it's really better to have it as a rolling update to avoid downtime. And there are things like replica sets, and there are ways to manage all the replicas. But this is beyond the scope of this video, and it's very easy, by the way. It's not hard. So I will delete these two lines for that reason. This is my pod configuration. So again, the label is hero. What is the image? I am using Lasirani slash hero, right? And I can see latest, but but by default it's latest, right? So you can actually omit that. The name is hero, of course. And we are going to pass the same environment variable, except this one. I mean, we can pass it, but like, why, right? So I think I called this database, correct? So let me call this database. And again, it's the same thing. And let's call this user. And let's call this password. And why am I calling them? It's the same thing that I called in when I modified the user.js. So when I initialized the user, I said user is process.inf.user. So I said that the environment variable is called user. That's why I am calling it user here. So whatever you named in the index.js, you would put it here. And what about the port? 3000, right? And this is hero. And we are not persisting volume. Actually, for most of your applications, if it's not a database, you do not want to persist volume. You want your pods to be stateless as possible. So this all can be deleted. And that is it. I think we are all good when it comes to this guy. And now I will go ahead and apply the file. And now it's created. Now it will take some time to be created. And if you want to read the logs, you can always say like kubectl logs and specify the pod. And of course, it's giving me some error because it's trying to create the containers. So they are like, dude, just patience, please. Now it's running. But as you can see, it ran very fast, like which is always amazes me. Now, how can I test my application? Now, since I'm using minikube, what you can do is you can run. Actually, I'm going to run this in a different terminal. You can say minikube service and provide the service name. If you forgot the service name, you can say get services and now minikube service and specify the service name. So that would be hero. And now I will go to users because this will list all the users. And now it's empty. So I will take that. And in order to create a user, I have to paste it here. Now the node is different actually. So this was like part of my preparation. So it's the same URL, but the node port is generated randomly. There is a way to generate the port, like to be specific about the port, but most of the time you don't need that. And since I'm creating a user, this is the name and this is the age. And I will click send. And as you can see, this is from my preparation for the demo. I will send this. Now I am created. Now if I refreshed, you can see that the user was created in the database. So that's great. Now we know for sure that our service is working correctly as expected. So now we are good with the service, with the deployment. So what is the last thing? The last thing is the Ingress, which is the API gateway. So as I mentioned, typically if you have a team with different microservices, you want the other teams to use the same URL, and you would specify different paths, different depending on your microservice. And for that, I'm actually going to, actually I can just stop this. I'm going to open, I'll just say like minikube Ingress, and I will follow the documentation. I think they have a very nice example here. First, you have to create the cluster minikube start. I have already done that. Now I've already done this step, so I don't need to. But if you are using minikube for the first time, make sure that you run this command. But I've done that already. It usually takes around a minute. And to verify that the ingress is enabled on my minikube, you can actually run. So let me go back here. You can run this command, and if you see some stuff, then you are good. If you've seen nothing, then your ingress is not enabled. And here we are going to create a Hello World app. And this is the second way. So the first way is to create a configuration file and apply it. But you can also create resources directly using kubectl. And that is the way. So saying create, and then whether it was a service or a pod or a deployment or whatever, and then the name of the deployment, and here he is referencing the image to the Hello app application from Google. And this is created. Now, if I said kubectl get deployments, done. Wow. Let's scroll down. I will expose the deployment. Now this, what does this do, by the way? This will create the service. So kubectl expose deployment, it will create a service for this deployment, which is the same thing that we did when we created our configuration file. And this will run on port 8080 in their example. In our example, it was running on port 80. But again, in the end, this will not matter that much because we are going to use Ingress, as we will see in a second. Now the service is exposed. And here I can like use the same trick that I did for the other application. So I can say minikube service and specify the Hello World app. And it will open a new thing in the browser. And this is the Hello World app. And here I'm going to create the Ingress resource using a configuration file. Let me stop this now. We'll go back here. Nano. And I'm actually going to do some modifications to this. Okay. Now, so just a small disclosure before we continue. In order to use Ingress, you need to have something known as Ingress controller. Now, there are different types of Ingress controller, but for Minikube, the Ingress controller that is provided by default is the Nginx controller. And that is why you see this annotation at this line, is because Minikube uses the Nginx controller, but there are different types. They are similar, but there are some differences. So I would recommend that you go and look into the documentation. And here I'm going to delete the host. I can keep it, but I will delete it for now, since I'm running this locally. And I'm using HTTP and the paths, and I will have different paths depending on the service, right? So since this is a Hello World app, I will reference the /hello to this to this web service, and I will create a new path for my other app, which is hero, right? Path type, prefix, backend, service name. And what was the name? It was hero, right? And what is the port? Where is it running? It's running on port 80, if you remember. And now there is just one more thing. What is that? So I mentioned the Nginx controller thing. So it has a lot of annotations. And just to explain briefly what I'm going to do. Actually, let me do what I want to do first, and then I will explain it. So Nginx controller, this rewrite target annotation is using regex. And if you are familiar with regex, it uses something known as capture groups. So this is defined as capture group. So this is capture group 1. And then if you had like a different capture group, this would be capture group 2, etc. So you can have a lot of control on how you want to reroute your services. And now since I want to reroute /hero/users from my application to /hero/users to the ingress, I said /hero/anything is going to be rewritten to be referencing my application. But again, you don't have to do too much about this. So that I just wanted to mention the reason why I'm doing that, because /hero has a nested route which is /users after /heroes. Now I'm going to save this, and I am going to apply it. Error validation. Let's see. Got map expected array. If you choose to ignore. Okay, so I did something wrong. Let me go back to the example. Path type prefix, backend service name, port number 80. Nothing seems odd here. Hmm. So let me exit. Let's see, delete the exception again. Validation inspection ingress.spec.rules. Invalid type for rules. Got map expected array. Okay. I just want to see uh the full example. So they appended this guy. I wonder if there's like some sort of a syntax issue. Spec.rules. Maybe there's like some sort of extra space. If this didn't work, then I will go to YAML validation. Now I can stop this video, but let's learn together, right? So, because this is something typical that you will see. Cats. Let's copy this guy. So this is a valid YAML, so this is not the main issue. So I did something wrong. Okay. Let's see. Let me delete this thing, even though I don't think this is the issue at all, but let's see. That's what I thought. Let me delete all of this, actually. Again, there's validation. So I'm pretty sure now that there is some spacing issues. So what I'm going to do is I'm going to take this. Oh, okay, now I know what the problem is. I know what the problem is. So I had to add this dash HTTP because I removed the host. So this had to be deleted. Okay. And now I will add my second path. Prefix. And now this should work. Okay, so now the ingress is created. And now here is the tricky part if you don't know what you're supposed to do. Now I know because I did a lot of research and a lot of people had issues with using Ingress for the Windows 11. So I will show you the trick on how to do that and I will save you hours of your time. Basically what you need to do is you need to run minikube tunnel and you need to provide the password. And now you'll see it standing like that, which is expected. And then you'll see a lot of comments saying that you need to use this IP address, which makes a lot of sense because if you did kubectl get ingress, and this specify the ingress name, you will see that it's referencing to the minikube IP address, and it doesn't work. It doesn't work. But once you do the minikube tunnel, it's actually tunneling to your local host. So the trick is just to use localhost, or you can use like 127.7.1, and then just specify the path. So the first path that we had is /hello, and the second path was the hero, and that's it. So that is the trick on how to run Ingress on your local machine on Windows 11. And that's the end of the video. Thank you very much for watching. I hope that you enjoyed, and see you very, very soon. Goodbye.